A typical swallow has a wingspan of 0.318 meters and a chord length of 0.043 meters. If we assume standard air, a density of 1.2255 kilograms per cubic meter, and that the swallow has a mass of 19 grams, and its wings provide a coefficient of lift of 2.47. What is the airspeed velocity of an unladen swallow if it has maintained steady flight? And the second part of the question, if it grips a 2.27 kilogram coconut by the husk, what is the required airspeed velocity of the laden swallow? So we go and look at it, we're looking at steady flight, and because of that, we know that lift has to equal the mass. And so in this case, the mass of our bird, of our swallow, was 19 grams. And to turn that into, sorry, not lift times mass, lift has to equal weight. To turn that into a force, 9.81 meters per second squared. And once I do that, that's going to give me grams per meter squared, grams meter per second squared, which is not a Newton, because a Newton would be a kilogram meter per second squared. So we'll throw into that 1 kilo is 1,000 grams. And so when we do that, our weight will be equal to 0.186 newtons of weight. So our coefficient of lift is equal to our lift force divided by rho over 2 velocity squared planform area. We need to rewrite this for velocity. And so our velocity is going to equal our lift divided by rho over 2, coefficient of lift, planform area, and we'll take the square root of that. So in our situation, velocity is going to be equal to 0.186 newtons divided by 1.2255 kilograms per cubic meter. Don't forget our half in there. Our coefficient of lift, which was 2.47. And then our planform area, 0.38 meter times chord length of 0.043 meter. And we're going to take the square root of all of that. So a Newton is the same thing as a kilogram meter per second squared. And so if we go and start canceling out units, let's see, 1 meter is going to cancel out a meter here. We'll have meters squared there. Kilograms will cancel. We're going to be left with meters squared per second squared. Take the square root of that. That'll be meters per second. And so that'll tell us that the airspeed velocity of an unladen swallow is going to be 3 meters per second. Okay, so now it grabs the coconut by the husk, and we go back up to this equation here, and instead of 19 grams, we have 19 grams plus 2.27 kilograms. And if I just go and quickly adjust those numbers, we're going to end up with 22.432 newtons. I'm assuming that you guys can handle that one on your own. And so now we just plug that back into our equation. And it's going to be the same equation, so I'm not going to re-derive it. Just going to rewrite it here. None of the units have changed, so everything's going to remain the same. 2.47 is our coefficient of lift, and we need to put our planform area in there. And that's it. So we're going to take the square root of all this stuff. And so once we do that, the airspeed velocity of the laden swallow is going to be 32.93 meters per second. So to take on that much more weight, it's going to have to fly 10 times faster.